The topic of this video is imperfect competition. Previously, we have seen that in the context of perfect competition, we have so-called price-taking behavior, in the sense that we have a lot of producers and we have a lot of consumers, and each one of them takes the price as given, in the sense that no matter how much they purchase or how much they produce, they are not going to influence the price. Under imperfect competition, we have a slightly different situation. Here, we are going to have price-setting behavior, in the sense that individual producers actually have the ability to set the price in the market. We will see that economic profits are possible in the long run, and remember that under perfect competition, we had the zero economic profit condition. So economic profits were not possible under perfect competition. Now, when you're looking at the market structure under imperfect competition, we are going to analyze two different structures. We are going to analyze a monopoly in the sense that we have one producer and many consumers, and we are also going to analyze an oligopoly. An oligopoly has few producers and many consumers. Now note that the perfect competition and monopoly are at the opposite ends of the spectrum, in the sense that under perfect competition, an individual firm has no control over the price, whereas in a monopoly setting, the firm has full control over the price because it's the only producer. Okay? Now, where things get a little bit more complicated and also more realistic is when we are looking at an oligopoly, okay, where we have a few producers and many consumers. Now, in an oligopolistic setting, we actually have that an individual firm has certain control over the price, but so do its competitors, okay? So the control over the price is more complicated because now we have a strategic interaction among producers. We are going to look at this strategic interaction among producers in the section on game theory. Now note that here we are looking at the imperfect competition from a producer's side, okay? But we can also have imperfect competition on the consumer side. And in that sense, or in that context, it would be called monopsony if we have one producer, or oligopsony if we have a few producers. Now, for the monopoly, as well as for the oligopoly, the basic problem that leads to the rise of this market structure is that we have barriers to entry, in the sense that it is difficult for a firm to actually enter the market. Okay? And there are many reasons of why this can happen. So, for example, we could have economies of scale in the sense that one or few firms can operate at a lower average cost than many firms, okay? So basically that the bigger the firm, the average cost is declining over the entire output range, okay? So here, when we are thinking about a natural monopolist, okay, then we are thinking about that this firm can produce at a lower price or at a lower cost the entire market than multiple firms. Usually, a natural monopoly occurs if we are having large fixed costs. So think about the firms that historically have been a monopoly in the US as well as elsewhere. Those firms are railroads, electricity companies, postal services, phone services, electric and natural gas, or water utilities, because there is a very large upfront cost involved. And hence, once those upfront costs are paid, it becomes cheaper and cheaper the bigger the market. Okay? But there can also be legal barriers that prevent entry. So if you're thinking about the protection of intellectual property in the sense of copyrights or patents, okay, or if you're having the control over a scarce resource, then we also have a barrier to entry. Now, the last barrier to entry that I would like to talk about is network externalities. So here, think about a situation where the benefit to an individual user or consumer of the service increases the more people are using the service. Okay, so think about Facebook or LinkedIn or any other social media service. Okay, then if you are the only person using social media, then you do not really get a benefit. But you get a benefit the more people use that same social media that you are using. Okay, so this would be also a barrier to entry. Now, let us have a look at a few monopoly examples. And also later we're going to look at oligopoly examples. Now, one of the prime examples that has been used for a very long time about illustrating the concept of monopoly is Microsoft, which had a monopoly in the market for operating systems or software in general. Note that this has led to multiple antitrust law cases in the US as well as in the European Union and other countries. Okay. Now note that there are also monopolies that are not so well known. So for example, it turns out that there is a French-Italian company that basically controls a large share of the global lens and eyewear market. Okay, eyewear in the sense of glasses and as well as sunglasses. Okay, so you may not have heard about the company, but you have heard about the brands. Okay. So here I'm listing, for example, Oakley. And you can actually check out their webpage and you see that there are many brands that this company is holding. Another example of monopoly is the company De Beers. Okay, again, this has been historically a prime example because they controlled a large share of the global diamond mining industry. Okay, in the sense that they had a monopoly on, they were owning the mines, and they also had a monopoly on this production. Now, note that the definition of a monopoly is not always clear-cut. Okay, so we said before that a monopoly is usually one firm and it has many consumers. But most of the examples that I have given you so far are not really clear examples of monopolies, in the sense that, yes, you do have one large company, but you always have a few smaller companies. Okay. Now, it is actually very difficult to find monopoly or to find pure monopolies that really fit the definition of just one producer. So we have to dig a little bit deeper. So let me start with the IUPUI parking. Okay, so IUPUI as a university in Indianapolis and also many other universities around the country, they have a monopoly on the parking spaces on campus. Okay, you can think about that there may be substitutes such as downtown parking or parking off campus, but the monopoly arises from that all the parking spots within the campus are actually controlled by one entity. And of course, they can set the price in that space. Now, internet providers are another example. Okay, so in Indianapolis, you have basically three large internet providers. Okay, and you could think that, well, this does not really fit the definition of a monopoly. But if you're thinking about the spatial separation of the territory they serve, okay, then you soon realize that there are some residents in Indianapolis that have only access to one provider, okay, which basically makes the particular internet provider in that area, in that small subsection of Indianapolis, a monopolist, despite the fact that it's not the only company serving the market for internet providers, okay, or for internet access. So there you have a spatial component that is part of the monopoly. And the last example that I would like to use is electricity transmission. Okay, So in the US, you have the electric utility generation, and you have the transmission of electricity separated, okay? And the electricity transmission works very much like a road, in the sense that there can be congestion, okay? There's only so much electricity you can use, or you can funnel through a particular line, or sometimes the roads can also be closed due to accidents or construction. Think about a downed power line, then that road or that transmission line is not used anymore, or cannot be used temporarily, or if we have construction going on and the power line has to be shut down. So now, depending on the circumstances, what can happen is that a particular transmission company can have a monopoly for a very short period of time, in the sense that they operate the only transmission line that is currently open and can transmit electricity through the system, okay? So this usually does not occur for a very long time, but they can have, for a short period, they can have that monopoly, okay? Despite the fact that there may be many other providers. Now, the cases before, we talked about a monopoly. Now, let us look at an oligopoly. Okay? Now, an oligopoly is characterized by a handful of producers, okay, and they are interacting strategically. We will soon see in this video what we mean by a handful of producers and how we can actually measure this. Now, an oligopoly, it is much easier to find examples for an oligopoly because it is a very common market structure. Okay, so here you can think about automobile manufacturers. You can think about that there's only a handful of automobile manufacturers, and even if you are looking down at particular markets, so for example the market for pickup trucks or the market for mid-sized sedans, then you realize that there's really just a small number. There is also a monopoly on the cell phone network providers in most countries. In the US, that would be AT&T, Verizon, and Sprint, which control a large share of the market. The same is true for cell phone manufacturers. Here I am listing Apple and Samsung, okay? But you only have a small number of providers. You have music entertainment, okay? You have Universal, Sony, Warner, and the EMI group that are basically providing you with music entertainment. Another example would be wide-bodied airplanes. So there is Boeing and Airbus that are controlling large parts of the market. But again, there are also examples here that are not as clear, or that are not as well known as, for example, Boeing or Airbus or cell phone providers. Here I have an example about mining. Okay, so if you are looking at precious metal mining, then you have companies like Glencore, Rio Tinto, Vale, and BHP that are controlling large parts of the global mining market. Okay. Now, the last example that I would like to use to highlight an oligopoly is actually when you're going into the supermarket to purchase goods, okay, or to purchase food. So when you go into a supermarket, what you see is that there are many different brands, okay? So if you're thinking about purchasing cereals, or purchasing candy, or purchasing water, if you're purchasing organic food, and so on. But it turns out that behind all those brands are only about 10 companies, okay? So you have the Swiss company Nestle, you have the US company PepsiCo, General Mills, Coca-Cola. I think Danone is a French company, and so on, okay? And so they are controlling all those different brands. When you're looking at this picture in more detail, what you also see is that you find a lot of brands that claim to be that not claiming is not the right word, but that are organic companies. Okay, usually consumers associate organic with a small local company, But when you're looking long enough on this graph here, you will see that there are a lot of organic companies that are owned by a large conglomerate. Okay, so this gives you an introduction in on monopoly and oligopolies. Now let's turn to the output decision of a monopolist. Note that the profit maximizing condition for a monopolist is the same as before, in the sense that marginal revenue is equal to marginal cost. So remember that if the marginal revenue is bigger than the marginal cost, or the additional revenue you are getting from selling one additional unit is bigger than the additional cost from producing that unit, then you are going to produce that unit and going to sell it. Okay? Now, in equilibrium, we have marginal revenue equals marginal cost. Now, under perfect competition, we have seen that the marginal revenue is equal to the price. Why is that? Well, remember that under perfect competition, all agents in the market or all market participants are what are called price takers, in the sense that no matter of how much they are buying or selling, they cannot influence the price. So the price is constant, and hence if a firm sells one additional unit, the money they are getting is equal to the price, okay, which then corresponds to the marginal revenue. Now, to see that under perfect competition and under monopoly we have this condition that holds, let us look at two graphs. First, let us think about the situation where we have perfect competition. Okay, so keep in mind that with perfect competition or with the monopoly, that the revenue of a firm is equal to price times quantity. Okay, so under perfect competition, the price is fixed. Okay, so it's a constant. So suppose it is $5. What this means is that if the quantity is 0, then the revenue is 0. Okay, but other than that, the revenue is increasing with the quantity. Okay, and the slope is constant, and the slope of this revenue line corresponds to the price. Okay, now assume that we have assume that we have a total cost function associated with this production technology, and assume that the total cost function looks like this. Okay, so the red line is the total cost. Okay. Now, the profit in this graph is represented by the vertical distance between the revenue and the total cost. So for example, if you are taking this point here, or if you're taking this point here, then the revenue is equal to the total cost, and hence here and here the profit is 0. Anytime the revenue is bigger than the cost, bigger than the total cost, we are having a profit. Now, as you can see, is that if the marginal cost or the slope, remember the slope of this total cost function is the marginal cost. So if the slope of the total cost function is smaller than the slope of the total revenue, then the profit gets bigger and bigger. Okay, up to the point. Okay, and I assume that this point is somewhere here, where the two slopes are identical. Okay, and remember that the slope of this revenue function is the price or the marginal revenue, and the slope of the total cost function is the marginal cost. And hence, this is where we have the profit maximized. Let's call this QC star. Okay, so for the quantity under perfect competition, that maximizes the profit. Okay, we have seen this before in the sense that price the slope of this function, of the revenue function, equals the marginal cost. Okay? So this is how a perfectly competitive firm would determine the profit maximizing quantity. Now, for a monopoly, the situation is identical, but a little bit, slightly different, yet slightly different. Okay? So let me first draw a picture here that illustrates the problem of the monopolist. Suppose that you have a monopoly. Okay, so you are a firm that is producing having a monopoly for a particular good, and your demand function looks like this. Okay, so note that for a monopoly, we are always assuming that the demand is linear. Okay, and later on it will become clear of why the demand has to be linear. So suppose that you are this monopolist and you are currently producing at, let's call this Q1, and you are setting a price of P1. Okay, so now for a perfectly competitive firm, if the perfectly competitive firm wants to sell more, what they can do is they simply increase the quantity, and they're going to since it's a perfectly competitive market, there's not going to be an effect on the price. Okay? So the price remains the same. However, if you are a monopoly, like in this case here, in order to increase the quantity to, say, Q2, for that to happen, you have to lower the price to P2, and you have to lower the price on all the goods, okay, that you're already selling. Okay, you cannot simply lower the price on the additional goods, but you have to lower the price on all goods. What this means is that the marginal revenue for the monopolist is not constant. Okay, so if we keep in mind that we have revenue equals price times quantity, in the case of perfect competition, the price remains constant. Now, as we have seen before on the picture that I just showed you, or on the graph that I just showed you, the price for the monopolist is not going to be constant if the quantity changes, because there is only one firm producing the good, and hence if the monopolist changes the quantity, the monopolist also has to change the price. Okay? So note that given the demand function, or given a demand function, let's get back to this picture here. Okay. So if the quantity of the monopolist is 0, okay, then you have a very high price, and hence the revenue, if it's P times Q, okay, if Q is 0, then the revenue is 0. The same is true if the quantity is very high and you have a price of 0, then the revenue is 0 again. So what this means is that for a monopolist, okay, if they're not selling anything, we have a revenue of 0. Okay, this is similar to what we have under perfect competition as well. But if the monopolist has a very high quantity, then the price, in order to sell that quantity, the price has to be equal to 0. And anywhere in between, we have a positive revenue. Okay, so then what this means is that the revenue function from the monopolist looks something like this. Okay, since it's positive for a particular range in quantity, and it is 0 at 2 endpoints, it has to be shaped like this. Okay, so now note that the marginal revenue of this monopolist corresponds to the slope of this line, okay, of this revenue function. Let me just highlight this, that this is the revenue function for the monopolist. Okay. And so you see that the marginal revenue, which is represented by the slope, is smaller here than it is, for example, here. But it turns out that in order to profit maximize, the monopolist is also going to set marginal revenue equal to the marginal cost. So let's assume that the monopolist has a similar total cost function like the perfectly competitive market. So we are just drawing it somewhere like this. Okay? And so this represents total cost. Okay? And then the profit for this monopolist is the difference between the revenue and the total cost. So as before, if the total cost is equal to the revenue, then we are making zero profit. Okay? But as long as the total revenue or the revenue is bigger than the total cost, that means that there is a profit. Now, remember that the slope of this revenue function is the marginal revenue, and the slope of this total cost function is the marginal cost. Okay? So there will be a point, okay? Let's say this point is here, okay? Where the two slopes are equal. Okay, so let's make it actually this point here. Okay, so here we have the slope of the revenue corresponds to the marginal revenue, and the slope of the total cost function is the marginal cost. Okay, and here you can see the vertical distance between the revenue and the cost is biggest for the monopolist, and hence this would correspond to the profit maximizing output decision for the monopolist. Let's call this Q star M. Okay. Now this is where the monopolist would produce. So you can see that the condition of marginal revenue equals marginal cost holds for both perfect competition and the monopolist, but under perfect competition, since the price is constant, the price corresponds to the marginal revenue, which is the reason why we set price equal to marginal cost. Whereas for the monopolist, the marginal revenue is not constant. Okay, but they are still equating marginal revenue equal to marginal cost. Now, it turns out that compared to the perfect competition, or compared to a perfectly competitive market, there is a deadweight loss or an inefficiency associated with the monopolist. Okay, and we are first going to look at this inefficiency or this deadweight loss conceptually, and then we are going to make two examples about constant and increasing marginal cost soon. Okay, so let us just look at the perfectly competitive market first. Okay, and keep in mind that we have the supply function, okay, and that supply function corresponds to the marginal cost function of the industry. Okay, we also have a demand function. Okay, and we have seen that price equals marginal cost. So in equilibrium, we have the Q star in a perfect competition, and we have the market equilibrium price, PC star. Okay. Then we have seen that we have a consumer surplus, which is the triangle above the price and underneath the demand function. So here we have consumer surplus. And the value underneath, or the triangle underneath the price and above the marginal cost function, is the producer surplus. Okay. And the sum of consumer surplus and producer surplus is the social welfare. Okay? And so now here you can see of why a perfectly competitive market is efficient, in the sense that the triangle here is maximized. Okay? Consumer surplus and producer surplus are capturing the entire area. Now, let's see what's going on in a in a monopoly situation. First of all, if we are drawing a demand function in a monopoly, then we are always going to use a linear demand function, okay? And it will become soon clear of why that is the case, okay? It actually makes the calculations much simpler. Now, in order, so we have the marginal cost function here. We have the demand function. And now, based on what I said above, if we want to find the profit maximizing quantity of the monopolist, we have to set marginal cost equal to marginal revenue. Now the question is, what is the marginal revenue in this graph here? So it turns out, and we will see this mathematically soon, that in order to find the marginal revenue for a monopolist, what we have to do is we have to take the halfway point. If we have a linear demand function, we have to take the halfway point on the x-axis, so here, and we connect this to the origin, like this. So this function here is the marginal revenue. So as you can see, if the monopolist is increasing the quantity, then the marginal revenue becomes smaller. Okay, this kind of makes sense. If you're thinking about if you're increasing the quantity, then you have to decrease the price. Okay, and hence you have a decreasing marginal revenue. Okay, so here we have the marginal revenue. And now we have the marginal revenue intersecting the marginal cost, and thus the quantity that the monopolist chooses to produce is Q star M. Okay. Now to determine the price the monopolist charges, we are extending the quantity up to the demand function. And then we are getting the price the monopolist sets for its products. And so the first thing you can see is that the price is higher than under perfect competition. And second, that the quantity is lower. Okay? But note that simply because we have a higher price is not the reason for the inefficiency. Okay? As we shall see now. Next. So first, let us do the consumer surplus and the producer surplus. So in this case, the price is higher, and hence we have a consumer surplus, which is represented by this area here. Okay, so the consumer surplus, let me abbreviate this with CS, is smaller for the monopolist than the perfectly competitive, than in a perfectly competitive market. Okay. We also have the producer surplus, which is everything underneath the price and above the marginal cost function. So here, this is the producer surplus. Okay. Now note that, of course, the producer surplus is larger for a monopolist. Okay, so here we have the producer surplus. But note that the problem is not that we have a higher price or that the consumer surplus is small and the producer surplus is big, but the problem, the inefficiency associated with this monopolist, is that we have this triangle here. Okay, so this triangle here before was part of the social welfare. Okay, because it was occupied by consumer surplus and producer surplus, but now we do not have that anymore. That triangle, since there are no quantities exchanged in the market beyond the quantity Qm, and hence we now have this triangle which does not belong to anything. And this triangle here is the deadweight loss, or represents the deadweight loss associated with the monopoly. Let us consider the case of monopoly output under constant marginal cost. In this example, we are going to have a demand function which is written as Q equals 50 minus P divided by 2, and the corresponding inverse demand function is P equals 100 minus 2Q. The inverse demand function is obtained in this case by simply solving the demand function in terms of P. The marginal cost in this case is $20, and hence the marginal cost is constant. Here in the graph below, we have the quantity on the horizontal axis, or the output quantity on the horizontal axis, and we have dollars, or also the price, on the vertical axis. So let us first draw the demand function in this case. Now, note that we are drawing the inverse demand function here. So the intercept is Q, and the intercept is 100. And then we have the slope of negative 2, and hence the intercept here is 50. Okay. So first, let us calculate the marginal revenue associated with this problem. First, keep in mind that the revenue for any firm is equal to price times quantity. Okay. Now, in this case, we have the price, of course, given the demand function, depends on the quantity. And so we can write this as 100 minus 2 times Q, which is the price, okay, times Q. So it is 100 times Q minus 2 times Q squared. So note that this class is not a calculus class, but if you take the first derivative with respect to Q of the revenue, then what you get is the marginal revenue. Okay? So the marginal revenue tells you that if you increase Q by 1 unit, what is the additional revenue you're going to obtain? In this case, the marginal revenue can be written as 100 minus 4Q. Okay. Now, this is the reason why we are always using a linear demand function when we are talking about the monopoly, because the marginal revenue curve associated with this problem is that the intercept remains the same, in the sense that the intercept remains the same as with the inverse demand function, 100, but we have twice the slope. Okay? So the inverse demand function, we have a slope of -2. With the marginal revenue function, we have a slope of twice that, meaning -4. And hence, if we have the demand function for the monopolist, so here we have demand, then the marginal revenue function is simply, you're taking the halfway point between the origin and where the demand function crosses crosses the axis, so about here, and we connect that to the origin. Okay, so note that for the monopolist, the marginal revenue function is not constant. Okay, or the marginal, so the marginal revenue is not constant. So here we have the marginal revenue function associated with the monopoly. Now, we said before that we are now in the case where the marginal cost function is constant, okay, and the marginal cost is at 20, and hence we have the marginal cost function that is a straight line. The marginal cost does not depend on the quantity, okay, and hence we have a straight line. And so this is the marginal cost, okay? Now, we mentioned before that the monopoly is maximizing output, or it's maximizing profits, where the marginal revenue is equal to the marginal cost, okay? And hence we can see that at this output quantity is where the two intersect. So in this case, it would be where marginal revenue intersects marginal cost, and hence we have the output quantity of a monopolist. And I mark this with QM here. Okay. Now we have this output, and hence in order to determine the price, we are extending the line all the way up to the demand function, and hence we are finding the price associated with the monopolist's output decision. So in this case, I call this PM. If you want to do the calculations, what you do is you are setting up the marginal revenue equal to the marginal cost. So in this case, we have the marginal revenue is 100 minus 4Q is equal to the marginal cost, which is 20. Okay. So when you solve this, what you do is you get 80 is equal to 4Q. You divide both sides by 4, and you get QM, or the monopoly output, is equal to 20. So here we have QM equals to 20. If you want to know the corresponding price associated with the output, you can plug the 20 back into the inverse demand function. So we would have 100 minus 2 times 20 is equal to 60, which corresponds to the monopoly price. So here PM is equal to 60. Now note that under perfect competition, or in a perfectly competitive market, okay, so if we have perfect competition, then the output quantity is where price equals marginal cost. So here we have the inverse. We would take the inverse of the demand function. So we have 100 minus 2 times Q equals the marginal cost, which is 20. So if you solve this, you find that Q under perfect competition, I mark that with QC, is equal to 40. Okay. So hence, under perfect competition, the output quantity would be 40. And since price equals marginal cost, we would have the price of 20. Okay, so that is under perfect competition. Now, there is a deadweight loss associated with this monopoly. Okay? And the deadweight loss is associated with the fact that the monopolist does not produce at the efficient or the perfectly competitive output. Okay? So the monopolist is not producing 40, but the monopolist is only producing 20. Okay? So in this case, the deadweight loss, okay, since only this quantity is actually exchanged in the market, okay, and this quantity here is missing, okay, it's not exchanged in the monopolistic market. That means that this triangle here corresponds to the deadweight loss of the monopoly. We are going to abbreviate this with DWL. Okay? So if you want to calculate this deadweight loss, what you have to do is you have to calculate the area of this triangle. So the area of a triangle is base times height divided by 2. So here you have to find out the base and the height. So here the base would be the difference between 40 and 20. The height would be the difference between 60 and 20. And you divide that by 2. And hence you have 800 divided by 2, which gives you a deadweight loss of 400. Okay, so that is how you would calculate the deadweight loss associated with a monopoly if the marginal cost is constant. Now, let us consider the case of increasing marginal cost. As before, we have the demand function, which is written as Q equals 50 minus P divided by 2, which translates to the inverse demand function of P equals 100 minus 2Q. But now, in this case, we have a marginal cost function which depends on quantity and is increasing. Let us first start by drawing the inverse demand function in this picture. So as before, it starts at 100, which is the intercept, okay? And then it goes by negative 2Q, and hence we have the intersection with the x-axis at 50. Okay? Like before, this is the demand function. Now, the marginal revenue function is identical as before. Okay, so we have the marginal revenue, which has the same intercept, but twice the slope, so negative 4Q. To draw the marginal revenue function, we have the same intercept, but twice the slope. And hence the marginal revenue function looks like this. So this is the marginal revenue. Now, in the case of the increasing marginal cost, note that we do not have an intercept. So if Q is 0, then the marginal cost is 0. So the marginal cost starts at the intercept, but is increasing with Q. So here we have the marginal cost. Now, like before, the monopolist sets the marginal revenue equal to the marginal cost. So in this case, we have 100 minus 4 times Q equals the marginal cost, which is 2 times Q. Solving this leads to 100 equals 6 times Q, or the monopoly quantity is equal to 100 divided by 6. Okay, so in this case, we have the marginal revenue equals the marginal cost. So the quantity set by the monopolist here is 100 divided by 6, which is the monopoly quantity. And this gets extended all the way to the demand function. And so we can calculate the monopoly price. We plug in the quantity into the inverse demand function, and this gives us 100 minus 2 times 100 over 6, and hence we have 100 minus 200 over 6, which is equal to 200 over 3. So we have this quantity here, okay, or the price. Now note that similar to the previous example, when we are looking at the perfect competition, or at the outcome that would prevail under perfect competition, then we are setting the marginal revenue equal to the price. Okay, we are setting the marginal cost equal to the price. So we would have 100 minus 2 times Q is equal to 2Q. And if you solve this, you find that Q is equal to 25. So that is the output under perfect competition. So this would be where the marginal cost intersects the demand function, and hence we would be here at 25. And to determine the price, you can plug in the 25 into the inverse demand function, and you would find that the price under the perfect competition would be 50. So we have the 50 right here. Now, similar to the case of constant marginal cost, we have a deadweight loss associated with the monopoly. Okay, so theoretically, the competitive outcome would be here, which would leave all of this area as the producer surplus, as the consumer surplus. It would leave this entire area here as the producer surplus. But now we are producing at this point here, and hence we have the deadweight loss associated with the monopoly, which is this triangle here. Okay. So now with the deadweight loss, we have to calculate the deadweight loss similar as before, in the sense that we have to calculate the area of this triangle, okay, which is the base times height. But note that now the calculations are a little bit more evolved. So let us first look at the base. So the base is the distance between the perfectly competitive output and the monopoly output. So here the base would be 25 minus 100 over 6 times the height. So here the height, the price is, let's write this as 400 over 6. and then you have to calculate the point, or you have to calculate the point here, which corresponds to the marginal cost at 100 over 6. So if you plug in the 100 over 6 into this equation here, you find that the marginal cost is 200 over 6. So here we have 200 over 6, and you have to multiply that by 1/2. Okay? And that, if you are executing this calculation, you find the deadweight loss associated with the monopoly. We have seen that a monopoly causes a deadweight loss and hence is inefficient. Now the question is, how can we solve this inefficiency? Or how can we regulate a monopoly? We are going to look at two policies. First, we are going to look at a per unit tax, and next we are going to look at a price ceiling. Okay? So when we have a per unit tax, or even before the per unit tax, let's just see of what the monopolist does. As before, we are setting the marginal cost equal to the marginal revenue. Okay? And this gives us the monopoly quantity and the monopoly price. Okay? So let me just mark the marginal cost here, as well as the demand function and the marginal revenue. So we have the marginal revenue, and we also have the demand function. Okay. Now, we said that if we have the monopoly producing at the price and quantity, then we are having a deadweight loss, which is associated with this triangle here. Now, one way that comes to mind is to simply say, well, if the monopolist reduces efficiency, then we have to tax the monopoly with a per unit tax in order to restore efficiency. So now let's see what happens if we are actually taxing this monopolist on a per unit basis. Remember that the line, the marginal cost function here, represents the cost for each additional unit. So if we are imposing a per unit tax, what happens is that the marginal cost line is going to increase because it is now more expensive to produce the good. So let's draw this new marginal cost, and that is the marginal cost with the tax. Okay. So now if we have the tax imposed, what the monopolist is doing, the monopolist again is setting the marginal revenue, but now it is setting the marginal revenue equal to the marginal tax, the marginal cost with the tax. So in this case, the monopolist is reducing the quantity even further. Let's call this QM prime, and the price is increasing to PM prime. Okay? Now, what happens to the deadweight loss? So we have now a deadweight loss which is even larger, because now we have this additional part here, which wasn't part of the deadweight loss before. So the increase in the deadweight loss from the tax is this piece here. Okay? So what this means is that a per unit tax on the monopolist is actually increasing the inefficiency. Okay? Or it's increasing the deadweight loss. Okay? So this is not going to work. Now, let us have a look at a second policy. And here in this second policy, we are going to have the price ceiling. So as before, let's assume that there is no policy, and hence we have the monopolist setting marginal cost equal to marginal revenue, which gives us the monopoly price and the monopoly quantity. Okay. and then assume that we are actually setting a price ceiling, okay, as before. Or we are setting a price ceiling as we have seen in previous chapters. Right? But here in this case, we are setting the price ceiling, okay, such that the price ceiling is equal where the marginal cost intersects the demand function. Okay? So now let us have a look of what is going to happen. Now, when we have the price ceiling, okay, then the monopolist would like to price at this point here, okay, but is unable to do so because everything above the price ceiling is not allowed. Okay, so then the monopolist could price right at the price ceiling. Okay, but note that if the monopolist then if the monopolist increases the quantity, okay, say from here to here, okay, then it is still going to get the money from the price ceiling, okay, or the price set by the ceiling. So in this case, the marginal revenue or the additional revenue the monopolist gets is bigger than the marginal cost, okay? And this is true all the way up to this point here. So then at this point here, the monopolist is setting the marginal revenue equal to the marginal cost, and this is going to be the new output by the monopolist. Note that this output here eliminates the deadweight loss, okay? And here we have that there is no deadweight loss anymore, okay? Here it is important to realize that the price ceiling, okay, so the function or the line which I have drawn here, okay, this represents the new marginal revenue by the producer, okay, and hence the monopolist is moving along this new marginal revenue line up to the point where the new marginal revenue is equal to the marginal cost, as we have seen before. And this eliminates the deadweight loss. Let us look at the relationship between a monopoly and the demand elasticity. Remember that the demand elasticity tells you something about how strongly the quantity demanded reacts by changes in price. Now, the very theoretical aspect to show the relationship between a monopoly and the demand elasticity is by using the so-called Lerner index. Basically, what the Lerner index measures is how far the price is away from the marginal cost. Remember that under perfect competition, price equals marginal cost, and hence the Lerner index in that case would be 0. Now, it can be shown that the markup, the difference between price and marginal cost, is related to the demand elasticity. So put differently, you can rewrite this equation as the price times 1 plus 1 over the demand elasticity equals to the marginal cost. So when you look at this part here, okay, the 1 plus the inverse of the demand elasticity, then you can see that if this term 1 over the demand elasticity is equal to 0, then we have the price equal to the marginal cost. For this term to be 0, the demand elasticity needs to be very large. Okay? Now, if the demand elasticity is small, then the markup is going to be large. Now, let us translate this theoretical treatment of the relationship between the monopoly and the demand elasticity, but let us have a look at it from a graphical perspective. Here I have drawn two graphs. One has an elastic demand and one has an inelastic demand. Elastic demand means that if the price changes by a little bit, then there's going to be a large change in the quantity demanded. Whereas inelastic demand means if the price changes by a lot, okay, or there's a large change in price, then the quantity demanded is only going to change by a little bit, okay? So let us first have a look at the elastic demand. And so we have the demand, we have the marginal revenue, and we also have the marginal cost. Note that the marginal cost is identical in both cases. So the monopolist in the case is setting the marginal cost equal to the marginal revenue. So we have seen that we have the quantity of the monopolist here, and then we extend this up all the way to the demand function, and we get the monopoly price. Okay, so P, let's call this PM. Now we know that the competitive outcome or perfect competition is where marginal cost is equal to price or equal to the demand function. So the perfectly competitive outcome is, let's call this QC, and we also have the price of PC. Okay. So the Lerner index or the markup is the difference between the monopoly price and the price of the competitive market. Okay. Now let us compare the situation where we have an elastic demand with the situation where we have the inelastic demand. Okay. So here again, the monopolist sets the marginal cost equal to the marginal revenue. So we get the quantity of the monopolist, and we also get the price of the monopolist, or the price the monopolist sets. Now, if we compare this to the marginal cost, or the perfectly competitive outcome, where we set marginal cost equal to the demand, or equal to the price, we have done QC here for competition, and we have PC here for the price of the perfectly competitive market. So you can see that if the demand is elastic, okay, so meaning that small changes in price result in large changes in the quantity demanded, then we only have a small difference between the perfectly competitive price and the monopoly price. Whereas if the demand is very inelastic, means that if large changes in price result only in small changes in the quantity demanded, then we are going to have a large difference in price. Okay, so think about this. Think about a monopolist who is producing, say, a life-saving medication. Then a large change in price is not going to affect the quantity by much. And hence, the monopolist is in a position where the difference between the perfectly competitive price and the price the monopolist sets can be very large. Okay, so this illustrates from a graphical perspective the relationship between a monopoly and the demand elasticity. If a firm has market power and can engage in price-setting behavior, then it can also engage in what is called price discrimination. Price discrimination means that the firm can charge different prices to different consumers according to their willingness to pay. Firms usually know that various consumer groups or consumer types have different willingness to pay for a particular product. Okay? So there are 3 degrees of price discrimination. The first degree is what is called perfect price discrimination, where each customer pays according to their willingness to pay. And this also results in no consumer surplus. One example here would be a Dutch auction. A Dutch auction works that the a good is auctioned off, and we start with a very high price where nobody would purchase the good. And then the price is decreased step by step, and the first person who says stop is going to get the good. In that sense, there is no consumer surplus because the person with the highest willingness to pay is going to purchase the good, and that person has also stopped the auction at their willingness to pay. So all the producer surplus goes to the producer, or all the social welfare goes to the producer. Then there is also what is called second-degree price discrimination. Here, consumer type is not observed, and consumers self-select into the different willingness to pay types. So for example, consider economy class, business, or first class on airplanes. If a person purchases the ticket, then the airline company does not know a priori whether that person has a high willingness to pay or a low willingness to pay. However, by selecting economy, business, or first class, the consumer self-selects into the different type. So if somebody purchases a first class ticket and there is a different quality, quantity attributes associated with that class, then the consumer has selected into the high willingness to pay category. Okay. Now, there is also something called third-degree price discrimination, where the consumer type is observed. So think about, for example, discounts based on student status, or whether you are a senior at movie theater or at the museum. Note that all those price discriminations have the goal to maximize the profit of the company, okay, or of the firm. So think about the third-degree price discrimination. If you have a student discount, this is not because firms would like students or that they like seniors, but based on that discount, they can actually increase their profits as opposed to having a single price. They can increase their profits from those groups because they know that students and seniors have a different willingness to pay. When we talked about an oligopoly, we said that an oligopoly is characterized by a handful or a few firms. Now, there is no clear-cut definition of what handful or a few firms mean, but let us consider some measures that can shed light onto this issue. Now, first, when we are talking about an industry, we have to somehow define an industry and which firm it comprises. In the United States, you can do this by using the North American Industry Classification System, or NICS for short, which is a classification system developed by the US Census Bureau. And basically, it takes a particular firm and then attaches a code to that firm to define its industry. Okay, so there are various subgroups and larger groups, and like the top level groups are, for example, agriculture, forestry, fishing and hunting, mining, utilities, construction, manufacturing, and so on. For example, all the manufacturing firms, they start with a code of either 31, 32, or 33. Now here in this table, I have picked 4 industries. Okay, so the first, note that they are all starting with 31, 32, or 33. So those are all manufacturing firms. And here in this case, we have the first industry subgroup is tanks and tank component and military armored vehicles. The second industry, we have pet food, we have quick print, and we have concrete, ready mix concrete manufacturing. Now you can see that in the first category, we have a total of 61 firms, and they are having sales of close to $11 billion. Okay, you see that you have a lot of ready-mix concrete manufacturing firms. you have almost 2,460 in the United States. Okay. Now, what we are going to do next is we will see of what those measures here on the right-hand side are going to mean. The first four categories are what are called the concentration ratio, and the last column here shows the Herfindahl-Hirschman Index, or HHI. So let us first look at the concentration ratio. Okay, and the concentration ratio, let's call it CR, is defined as follows. You take the N leading firms and you take the firm sales, okay, or the sales of an individual firm, okay, of firm I, and you divide it by the industry sales. Okay, you multiply this by 100, and you take the sum of those individual measures. Okay, now this means that, for example, if we take in this case, if we take the first largest, if we take the first column here, which is the concentration ratio of the 4 largest firms. What this means is that in the business of, or in the industry of tanks and armored vehicles, the 4 largest firms almost have 81.8% of the industry sales. Okay, so this means that the remaining 57 firms only have about 18% of the market share. Okay, so this would give you an idea that the first industry is highly concentrated. Now, if you compare this to the quick printing business here, okay, then the 4 largest firms only have a very small market share. Okay, and even if you're looking at the 50 largest firms, you only have, they only represent 17.4% of total market share, okay? Which means that this industry here is not very concentrated. Now, the HHI is a little bit more evolved and does not require that you choose the number of firms that you're going to aggregate. But the calculations here are very similar. But here you are summing up over the entire industry, and you take the firm sales of a particular firm I, you divide this by the industry sales, and note that this measure here, as well as here, gives you the market share of an individual firm. And you multiply this by 100, square it all up for every firm in the industry, and then the result will give you the HHI. Okay. Now, before I talk about the HHI in the context of those 4 firms, let us do a little example here first. Okay. So here, consider that we have 3 industries, and those industries are called A, B, and C. Okay, and in each industry we have 4 firms, and those numbers here represent the revenue or the sales associated with each firm in each industry. So here we have, for example, revenue on sales of 30 that is associated with firm 1 in industry A. Now, when you look at those numbers here, then you see that industry A is the least concentrated in the sense that each firm has the same market share. Industry B is characterized by a firm that is very large, which has a sales of 84, and then 3 smaller firms, whereas industry C is characterized by 2 large firms and 2 smaller firms. Okay, so let us calculate the let us calculate the concentration ratio, or the CR2, for those industries. So how we do this, how we are going to do this for industry A. Let's call this industry A. So here we would be taking the 30 divided by the industry sales of 120 times 100 plus the sales of firm number 2 divided by 120 times 100. And then if we are executing this calculation, we get a concentration ratio for the first industry of 50. Okay. Now, if we do the concentration ratio for industry B, and again, we are looking at the two largest firms, okay, so 84 and 28, then we get 84 divided by 140, which are the industry sales, times 100 plus 28 divided by 140 times 100, and we get a concentration ratio for industry B of 80. Okay, so here we see that since what 80 means is that the two largest firms are controlling 80% of the market in this industry. Now, let us calculate the third industry, or industry C. Okay, so here we have 114 divided by 280 times 100 plus 110 divided by 280 times 100. And now here, when you are doing the calculations, you find that again you're getting a concentration ratio of 80. Now here you can already see that there is a little bit of a problem if you're comparing industry B and industry C. We said that industry B is more concentrated because you have this very large player and you have three smaller players, whereas industry C you have two large players and two smaller ones, yet their concentration ratio of those cannot distinguish between those two industries. Okay. Now, this is where the HHI comes into play, because we are not only looking at two firms, but we are actually doing all the firms. Now, let me just calculate the HHI for industry B. Okay. And calculating the HHI for industry B serves as an example, and the calculations are identical for the other industries. Okay, so here what we do is we are taking the first firm, 84 divided by the industry sales of 140. We multiply this by 100, and then we square. And then we do the same for the second firm. And note that what happens when you are squaring the number is that outliers, or firms which have a very large value, are actually getting more weight. Okay? So here we are having the third firm, and then we can also do this with the last firm. And this is, of course, squared and not cubed, okay? And then when you do the calculations, you get an HHI for industry 2 of, and let me write this down here, of 4,209, okay? Now, when you do the calculations for the other industries, then what you get is for industry A, you get an HHI of 2,500. And for C, you get an HHI of 3,417. Okay? So now note that here we have the HHI is higher the more concentrated industry is. So here we said that industry B is the most concentrated. We noticed that intuitively at the beginning. And so you can see that this is also reflected by the HHI, which is higher for industry B than it is for industry C. Okay? And so the maximum HHI would be actually a monopoly. So the HHI of a monopoly would be equal to 10,000. And under perfect competition, when each firm has extremely small market share, then the HHI for perfect competition would be approximately 0. Okay? So the HHI is between 0 and 10,000. So here again, this gives you an idea about how to measure the market concentration and tell you something about the industry that we are dealing at. So if we are getting back to the to the 4 examples, okay. So you can see that, for example, Quick Print has a HHI that is extremely low at 8.4. Okay, so there is a lot of competition in this industry. However, you have tanks, and you can see that also pet food are actually very similar in terms of concentration. Okay, because with the pet food industry or dog and cat food industry, you see that the 4 largest firms have almost 71% of the market share.